Hi everybody, it's the notes for Tuesday, April 21st, and we're still in Chapter 6, Section 1, but now we're going to look at the area of an oblique triangle, and remember oblique simply means it's not a right triangle. So I've gone ahead and drawn a triangle and labeled it, and remember the sides opposite the angles have the little letters and the angles have the big letters. So we know how to find the area of any right triangle. The normal formula for the area of a triangle is 1/2 base times height, but the base and the height have to be perpendicular to each other. So now what we have is a triangle where we don't have two perpendicular sides. So it's really a nice little formula. I'm going to go ahead and write this down. And the area, it still starts with 1/2, but now it's 1/2 of one side times a second side times the sine of the angle that's between those two sides. So if we're looking at side B and C, then angle A is between those two letters. And you can see that here. Here's side B, here's side C, here's angle A. But it's always going to be really easy to tell whatever two letters are used here, the other letter is used for your angle. All right, so for example, let's go ahead and do a couple of examples. The notes are kind of short today. So we're going to find the area of triangle ABC given. Okay, so we'll be given a couple of different pieces of information. So number one, suppose we're given that angle B is 102 degrees, that side A is 90, and side C is 52. And so it's just 90 units, 52 units. Sometimes they may tell you meters or inches or miles or things like that. But if there's no unit of measurement, then it's just units. All right, so the area of this triangle, it very well could be this triangle, of course not drawn to scale, where we have the length of side A, we have the length of side C, and we're given the measure of angle B. So according to our formula, and notice our formula now is written when we're given angle A. We're not given angle A this time, we're given angle B, but we can rewrite the formula with the right information for this particular problem. So our area is going to be 1/2 times one of the sides, so in this case that'll be 90, times another side, 52, times the sine of the angle that's in between them. In this case, that's going to be sine 102, and they are all going to stay really this easy. So again, make sure your calculator's in degrees, and just multiply this out on your calculator, round to the nearest hundredth. This is 2,288.87. Some of the easiest math we've done in a while. And I'm going to remind you, you don't have to memorize this formula. You're always going to be able to use a formula sheet here. One more example and we'll be done. All right, so example 2. Suppose you're given that angle A is 80.3 degrees, that side B is 24.5, and we need side C then. It's going to be 18.1. They're not going to be tricky with their information. They're always going to give you two sides and the angle that's included between them. So our area is going to be 1/2 times the two sides, so that's 24.5, times 18.1, times the sine of the angle between them, so that's going to be the sine of 80.3. And again, just throw that in your calculator. 1/2 you could put in as 0.5 times 24.5 times 18.1 times the sine of 80.3. And this is going to give you an area of 218.56. If these were, let's say this was meters, then since we're doing 24.5 meters times 18.1 meters, meters times meters means that our answer would be square meters, or meters squared. An area is always going to be in square units, square miles, square meters, square inches, whatever the unit of measurement is there. So that's it for the notes for today. I'm going to go ahead and give you your homework assignment here instead of putting it as a separate thing on campus this time. So homework is going to be that same page you did yesterday, page 414, and just doing numbers 19 and 20. And remember to submit your work on campus. And that's it for today. Thanks.